Okay, so in the last film, I used this problem as an example. Iron reacting with chlorine gas to produce iron Roman number 3 chloride. What I'd like to do is to play off of this, and instead of making this one my x value, we can actually solve to create how much iron we actually needed for this reaction. Remember up here, I said in the problem excess of iron, but I can actually even solve for how much iron is going to be needed. So this is what I like to tease the beauty of the beauty of stoichiometry. If you have one known value at all in the problem, you can solve for all the other ingredients and components of the equation. So let's do that. Let's say we want to solve for how much iron was needed. So I can just go ahead and start with the known value that I started originally with 5.0 grams of chlorine gas. And I am going to, of course, the first step is repeat it again at 1 mole over 71 grams. You will see then I am canceling out the grams of chlorine and converting it to moles of chlorine. And in the balanced equation, 2 moles of iron are needed for every 3 moles of chlorine gas used up. So this cancels off our moles of chlorine. But I am switching over to the unknown this time is the iron, not the iron 3 chloride. Notice how the stoichiometry and the dimensional analysis keeps you on track. But this time, I am going to convert back to grams using the 55.8 grams off the periodic table of iron per mole, which is our molar ratios. Now, when I solve this whole problem, I come up with 2.62 grams of iron is all that I needed to make this reaction go to completion by theory. Or you can see here that I could have used the 7.62 grams that I solved in the very first video problem. I could have started here to solve my same thing, except my setup's just a little bit different. I convert the iron 3 chloride, the 7.62 grams, to the mole, which we learned earlier was 162.3 grams of iron 3 chloride. But now my mole to mole ratio switches over to the crossover step, the crucial crossover step. 2 moles of iron are needed for every 2 moles of iron 3 chloride that's produced. And then I just convert that again with the step I did up above, 55.8 grams of iron for every 1 mole. You will see that in terms of canceling out. You have grams of iron 3 chloride cancel off, moles of iron 3 chloride cancel off, moles of iron cancel off, and by the way, even the 2 and the 2 cancel off too. So that's kind of nice. So all you need to do then here is take 7.62 times 55.8 grams divided by 162.3 grams, and you'll come up with an answer that's 2.62 grams of iron. See how it matches up with the one you did with the other known 5.0 grams. So I could even play with this a little bit further. I could take this known value and solve for how much chlorine gas and your answer should come out to be 5 grams as well. So again, what I call the beauty of stoichiometry.